right, welcome. So there is a playground assignment called Structures, and it looks something like this. And on page 8 of Structures, there is this challenge here, the Instance Methods challenge with the rectangle and with down at the bottom the song. And so this time in the semester, I like to see where students are at, so I'm not going to give you the solution to this problem, but I will give you an example that will get you very, very, very close to the solution. So let's go ahead and get started here. I'm going to open a fresh playground here, and we'll go through the coding concepts you're going to need for this assignment. So up at the top, they have you work on a structure up there. And to get this kind of going, I'm going to think of this as far as video games, right? So I'm going to make a structure and call it a character. And open and close curly braces. I'm going to give each character strength and intelligence. And I'm going to even throw a function in there similar to the one they've got, where it is going to be checking if the character is stronger than the other character. We could also, of course, create another one that is smarter than. So this is a structure. We've got strength and intelligence, and we've got these functions inside of a structure. Now, functions inside of structures, sometimes they call them methods. And it's just a function that's inside of a class or a structure. We'll call them methods. When we talk about, they're talking about instance methods, that means that you have to create an instance of a character to actually execute this function. So for instance, let's make a character down here and call him Beefcake. It would be ironic if Beefcake was really weak, so we'll just make it obvious. Character, and when you create the character, now it's going to want these things. We'll throw Beefcake's strength up to 18 and intelligence down to 8. Okay? And so we've created now an instance of a character here. What they mean by instance methods is this function you can only call this function once you have a character. So now you can say Beefcake dot is smarter than or is stronger than, and that's an instance method. Now we need another character to check Beefcake against. So let's go up here and make another character. Brainiac. Ooh, maybe I'll make it like all French. Brainiac. Assign to character. Be very similar to Beefcake, except maybe just the opposite. Strength is 8, intelligence is 18. So is Beefcake smarter than Brainiac? Well, let's check. So right now it says false, no. And it's returning this bool. So we could assign it to a property here, like let's assign it to that. That would assign that false to that is Beefcake smart property. But in this case, we're just going to kind of leave it like that. And how does it work? Well, let's take a look. So there's a function, and it's spitting out a bool, true or false. What's it taking in is inside these parentheses. In this case, it's taking in the other character. And it's of type character. So when I see this, I think other character of type character. And that's what's going into the function. And inside the function is between these curly braces, and all it's doing is checking if the strength is, in this case, the strength is greater than the other character's strength. So if the instance character's strength is greater than the other character's strength, well, then just return that. True or false. And same thing goes for smarter than. So hopefully that makes sense. There's a function is smarter than. Now this little line here just makes it so we don't have to put this extra word in front of this. So if we don't have this underscore there, then it's going to want us to have this down here, like that. So Beefcake is smarter than other character Brainiac. And that reads fine too, but I think in this case I like the underscore better, which just means, hey, don't even ask for that like descriptive thing. So I'm going to go ahead and hit play again here, make sure I didn't break anything. Great. Okay, so then they're going to say, hey, but we want you to add an extra function inside of here. Actually, they want it to be a computed property, right? Let's see here. Yeah, Then I want you to make a computed property inside of here. So let's think about something. Let's say there's a variable and we're going to call it super smart. And we're going to, it's going to be an integer. So you'll see already we're doing something a little different. We're not making a function. We're creating a property. And we're calling it super smart. And it's going to be integer. And then we're going to assign it to return, let's say the intelligence of the creature times 2 or times 3, super smart, right? So what this is going to do, it's called a computed property. We actually don't put the equals in there at all. You just return, it just calculates this and spits it back. So now we could maybe make Beefcake super smart. And when we call Beefcake super smart, it's going to spit out the intelligence of 24, right? That's a super smart Beefcake. Now, it's probably important to note that it's not actually changing Beefcake's intelligence. So Beefcake's intelligence is still 8. It's just this is the super smart version of Beefcake would have an intelligence of 24. So it's a calculated property. If we wanted to change Beefcake's actual intelligence, then we could potentially maybe do something like this. And then let's see if it works. Now it's probably going to yell at me here because this is a let. It says you can't assign a property because it's a let. So if Beefcake was variable, like Beefcake could change, then let's see. It still hates me because we said up here this is supposed to be a let also, but now we're going to make this variable up here as well so it can change. And now suddenly Beefcake's intelligence is permanently boosted. Okay, so this should get you through the top part of the assignment. They're going to ask you to make a computed property here. This is how you make a computed property. The second part of the assignment, they give you a structure down here, and it's like a song structure, and they've already got an array of songs. And so let me go ahead and paste a different structure down here for you. So they're going to give you something like this, and actually up here it says, you know, code from page 6 paste here plus the new method. What they're saying is, like on page 6 you've got some kind of a formatted thing, maybe something like this that you paste in there from a previous page. And so what I got here is a structure, and I'm using video games again. So the title of the game, the system it was released on, the year it was released. Then I've got a couple of computed properties here. One is how many years ago was it released based on today's date. There's actually a fancy way to get today's year, but I'll just leave it like that for now. And formatted title, I think that's also from a previous page, and I'm just returning a string here. And then I've got a bunch of games, old games, new games, different games. So in this case, Yar's Revenge for the Atari 2600, some really cool audio in that game. I sampled that for music a long time ago. Then there's the classic game Halo. I'm just talking about Halo 1, released on the Xbox. Space Invaders, 1978. I was very, very little when that was released in the arcade. We got Destiny, of course, released in 2014, and we have a classic that I used to love as a child called Jumpman for the Commodore 64, released in 1983 for a very young 8 or 9-year-old Dave. And then I've created an array from them. Now, I think the book creates the array with all of these things, like kind of, they don't actually create like instances of each of these, but I like creating instances of them. That way it's easier to like read down here. These are the games we got now that we're going to look through. An array, a collection, an ordered collection of games in this case. So it's an ordered collection of games. We don't have to do this, but sometimes it makes it a little bit more obvious what we're doing if I put the colon and of type game. Okay, this is also important if you want to start with a empty array. It'll make you say, well, what kind of array is it going to be here? So this makes it easier for the compiler to know what's going on. Okay, enough talk. Let's get down to the assignment here, right? And it asks us to make a method, which means a function. So a function inside of a structure. So in this case, is older than. I make that. And it's going to say, yes, it's either older than. It's going to take in another game, and it's just going to do some calculations to see which is the oldest game. The new one, the instance game, or the one we're checking it against. Which one's older? So that's the method that it wants you to create. It also wants you to spit out like information about that. So I'm going to create another property. It's a computed property. In this case, it's the computed property. And it's not computing much other than just spitting out two strings together. So it's going to get this string and spit it out. Now you'll see when you do a computed property, you don't need this little arrow return statement. You just kind of throw the curly braces right after the property without the equals or anything like that. And it's very strange, but that's how it works in Swift. And so now we've got the method, and we've got the computed property, and now it says, hey, well, tell me which game is the oldest. So how do we do that? Well, I mean, we can just say, is Halo is older than Yar's Revenge? Oops, I used the dot there. That's not right. So we could do something like this, but that's not checking all of them. That's just simply checking Halo. Is Halo older than Yar's Revenge? No. So what we got to do then is we got to go through this whole list of games here and figure out which one's the oldest. So the way that they want you to do that in this case is not, you don't have to do it this way, but the way they want you to do it is create a new game called the oldest game. And I'm going to assign that to game property. And I'm just going to say the title is unknown first, because we don't know which one's the oldest one yet. And I'm going to say it was released in 2022. So I want to start the date like this year, so that like I know that we're checking. This is clearly not the oldest game because it was just released this year. So I'm making a game. And then I'm going to go through each of the games. So for this game, in all of the games we have on our shelf, and then that's the for loop. Now we got to do that check, right? So if this game is older than, if it's older than the oldest game we have, then now the oldest game we have is actually this game. Does that make sense? So we're going through each of them. We're checking to see if this game is older than that game. If it is older, then we've got a new oldest game, a new winner. And so it's going to go through and it's going to check to see what the oldest game is. Then down here, we can simply print something out that says the oldest game in the array listed is, and then I'm going to use string interpolation and take the oldest game and print out the information. So the information it's printing is this information property we made, where it's just going to spit out the title on the years ago. So let's go ahead and see. It should be that Space Invaders. It should be Space Invaders. The oldest game in the array listed is Space Invaders, which was created for the arcade. Space Invaders was released 44 years ago. Whew. That's amazing. I am quite old, is what this assignment is showing me. Anyhow, this should hopefully help you get through that assignment. This takes you through the bottom of page 8. Not an easy page, asking a little bit of you, but this should hopefully get you close. Again, I don't like to give out the actual solution for this one because I'd like to see where you're at in this stage of the class. I'm going to actually paste a link to the code in the description of this video down below, so go ahead and click on that link and you can copy and take a look at the code. Otherwise, take care everyone. Stay safe out there.